Okay, guys. I'm going to try to explain to you some of the parts to U2A2 summation notation, which may be a little different to you. So, summation notation is represented by the letter sigma, the Greek letter sigma, the capital letter sigma, which looks like that. So, almost like a sideways M, like that type thing. And what that means is let's add a bunch of stuff up together. So it is, so this here is the general formula for summation notation. And this is saying that we are going to get the sum of whatever this is, AK, so these terms, all the way from the first term, so K being number 1, to Kn. So this says add up to me, sum, right, summation, add up all the terms that of the form AK, starting at K1, which is the first term, A1, and keep going, A2, A3, until you get to the nth term. So if you're going to use this for practical things, you probably will have a whole number here. So you want the first 7 terms or something like that. So this would be 7 up here, and then you might change this also. We'll go through a bunch of examples too. That's all about. So for example, this guy right here is saying, start with the K being 1 and go to K4 and add up this expression. Okay, so this is K squared. So the first one will be 1 squared, 1 minus 3, and then you're going to add to that 2 squared, 2 minus 3, and then you'll add to that the next term and the next term. There'll be 4 of them. So then it'll be 3 squared, 3 minus 3, and then plus 4 squared, 4 minus 3. And then just figure out what that is, 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 and then add them together. So that's what's going on there. And if we skip to the next page, it goes over some definitions here. The lower limit, and let me just change my color here if I can do that. The lower limit and the upper limit. So lower limit says, where do I start? So that was the 1, and I go to 4. So I want the first term to the 4th term. And then when you do that here, exactly what I did earlier, just with different brackets. And then when you add them up, you get a total, which is your answer. Okay, so in this case, it's 10. You can keep going with this note here. And it just shows that usually K, the practical use is that K or L, or the common use is that K, L, or M happen to be used as the variables, not X and Y and that sort of thing. Okay, so here it's the first, we're starting off with this here is a different example, and then we're looking at some of the properties of summation notation. So this is what I got a few questions about. So this is why I'm making the video here. So this is a constant can be factored out in front of summation. So this is saying that you can do a common factor. So let's think about this for a second. If I had the terms 3 plus 6 plus 9, and I want to add those up, I can add those up, okay? Or I could say, hold on a second, I can factor out a 3 out of that whole thing. So each term can be common factored by a 3. So if I did this here, I get 18. And if I did this, 1 plus 2 plus 3, that's 6 times 3 is 18. So that's saying the same thing here. This is saying if you can common factor, if you have a common factor here, you can take it out. Now notice there's no variable associated with this. Okay, so when you're factoring, it has to be a constant, not a variable. Okay, so it can't be C to the K or whatever. It's just a whole number here can be taken out and put in the front, and then you can get the sum of these terms here and then multiply it by 3. Why you would do that is that your answer, the work itself might be a little easier when you're dealing with smaller numbers here. Okay, for a binomial, you can split this up. So what this is saying is if you have something plus something, you can break that up into the sum of the first something and the sum of the second something. Okay, so and the same thing with this, addition is also subtraction. So if you have a bunch of terms, you can add them up. So if I had x squared plus x, okay, for example, and I wanted the first 3 terms here, let me just do this real quick. If I wanted the first 3 terms, I'd have 1 squared plus 1, which is the first term, and then 2 squared plus 2, and then 3 squared plus 3, and you can put brackets here if you want. You don't have to. And let's just figure out what that is. Oh, someone's calling me or something. So that's 1 plus 1 is 2, plus 4 plus 2 is 6, plus 9 and 3 is 12. So you add those up and then you get 20. Hopefully I don't mess this up. Or you could do this part and then this part. So this is saying you can get the sum of the squareds of x squared. So you can sum up the x squareds. So that'd be 1 plus 4 plus 9. And then you can just do the x's, which is 1 plus 2 plus 3. And then that's 6 and that's 14. And if you added those up together, guess what? You get 20. Okay. And the same would happen here. So these are just breaking things down. Sometimes they help, sometimes they don't. Okay. What else is there? Common summation notations. So you have this one here, a constant added to itself n times. So that's when you just keep adding something. So it's going to be 2 plus 2 plus 2 plus 2 plus 2. And this is just saying, this is a little bizarre, is that is saying if you do that 4 times, that's the same as saying that's 4 times 2. Okay, so very, very straightforward. But I think the key is to play around with these and understand what is this saying to me. And this is saying, okay, hold on. I want the first, I want c times n from k equals 1 all the way to up to n. So that means I want c1. Sorry, I'm just adding up. Sorry, I misspoke there. What I want here is c. Forget this part here. I want c plus the next term is going to be whatever c plus c plus c. There's no k involved here. So that's why this looks a little weird. Is it's not c times k or c to the power of k or something like that. It's just plain old c, some constant. So if you do that, what you're saying is do that n times. What you're doing is you're going c plus c plus c plus c plus c, and how many times is that n times? So that's the same as saying give me n times c. So the really basic thing. Don't get confused by this. It's a little a bit of a pain. This here is based on something some summation notation that if you took grade 11 advanced functions, probably not the mix, but if you took the university course, not advanced functions, grade 11 functions, you would have seen something like this when you did series and sequences. So this is saying that the sum of a certain number of terms is equal to this guy right here, which is n plus 1 divided by 2. So this is saying, this is a general way to look at this. And the way this works, why this works is, if you have a series of numbers, right, 1, 2 through n, let's just do this with 1 plus 2 plus 3 plus 4 plus 5 plus 6. I just like using concrete examples because then we can look back. If we add these up, this is 3 and 3 is 6, plus 4 is 10, and we're going to get 21. Okay, so that's great. But sometimes your numbers are way bigger than this. So instead of going from 1, you can go all the way to the end. And the reason this works over here is this is saying that if you take the first term, you can pair these numbers up. Okay, so you have a first term and a last term. So we have 1 and 6, and they add up to 7. And 2 and 5 add up to 7. And 3 and 4 add up to 7, right? And if you had a bunch of things like this, you take the first term and the last term, and you can add them up. So in our example here that I made a mess up, I have 1 7, 2 7, 3 7. So how many 7s do I have? I have 3 7s. And 3 7s is, not by coincidence, is half of the number of terms. So there are 6 terms. I divide that by 2 because I have 6 terms, but now I have 2 pairs. When I make the pairs, sorry, I'm going to have 3 pairs, and each of them adds up to 7. So when you look at that, that is this right here. Okay, you take your term, in our case 6, and you divide it by, you multiply it by 6 plus 1, and you divide it by 2. And in general, we have n times n plus 1 divided by 2. So that's how that works. Okay, if you're just adding that up. If you have the squareds, similarly, I'm not going to get into the explanations for this or for this one either, but these are the general equations for how to add up squares. So you have 1 squared, and then you have 2 squared and 3 squared, and you keep going, and there's a pattern that arises, and you can sum up all the squares by using this formula here. Instead of going, what is all this? You jam this whole thing. So for example, if I want to get the sum of the first 20 terms, okay, here, so 1 squared all the way up, all the way to 20 squared, what I will do is I'll use this formula here, and this is saying that I want to find, so how would I write this out? It would be, I want from the first term, to the 20th term, and I want to get the squareds of each term. Okay, so I want 1 squared plus 2 squared all the way to 20 squared. And what I can do here is my 20 is n, so look up here, that's n, that's 20. I can just use this right here, 20 plus 1, and then 2 times 20 is 40 plus 1, all over 6, and I'll get the total. Okay, so then that is going to, that's a 1 there. So 20 times 21 times 41, all over 6, and that'll get me the total of the first 20 terms. If you don't believe me, why don't you go ahead and try with something, something you can do a little bit quicker. Maybe use 5 squared, do that in your calculator, 1 squared plus 2 squared plus 3 squared plus 4 squared plus 5 squared, add them all together, and then go ahead and put it in here and see if you get the same answer. Okay, moving forward. So these are all explanations for how this works. You're not going to be forced to prove these things. But then if you go down here, you notice that in these examples, they did actually the first 50 terms here. And just using the knowledge, not the knowledge that we have, but using the short forms we have to help us out here. So this one here says, write the following using summation notation. So how does this work? Okay, check your answers for this and this. It gets a little tricky, okay? But what you want to do is continue to go back and forth and see if you can make sense of that. This one's difficult, but go ahead and check that out too. Okay, the answers are provided here. If you have any more questions, just send me an email. And if any of these really get you stuck, send me an email. If I get a couple of emails that are the same, or even one email, I can explain this to you. Okay, take care.